flip lesson 73 for the 6th grade. Today we want to look at exponents, right? And as we look at exponents, we want to follow some pretty basic rules when it comes to this. We've worked with exponents before. Normally we see it as a square, something like this, 2 squared, right? And we know that that means 2 times 2 because of the squared idea. And that's really the basic idea that we see in exponents. You see our first example over here, 5/3. What that really means is 5 times 5 times 5. Right. So that'd be 25 times 5, which would give you 125 for an answer. Over here we see 7 to the 5th power, right? So we see that it's not 7 times 5, but instead it's 7 5 times. So 7 times 7, 7 times 7, 7 times 7. And so we have that idea. Very, very different than just doing this times the 7 times the 5. So that's the principle that goes into exponents. Now, dealing with exponents then can be a little bit tricky in the sense that the numbers can start to play games with us, right? 4 to the 3rd, is it bigger or smaller or equal to 5 to the 5th? 4 to the 3rd, of course, is 4 times 4 times 4. So that's 16 times 4, which gives us an answer of 64. Or 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 is 243. And so in the end, we see that 3 to the 5th is much, much bigger than 4 to the 3rd. Here we have this idea, 9 squared, right? That's 81. And then 5 to the 4th, right? So even though we started with a larger base number, right, we're going to quickly see that 5 times 5 is 25. And times 5 is 125. Times 5 is 625. Excuse me, 625. And so in the end, we can see that that is bigger, right? And so we have those different ideas, exponents. Sometimes exponents can be useful because it can help us understand prime factorization better. We see the number 144. I've broken it down into primes for you. Divided by 2, get 72. Divide by 2 again, get 36. Divide by 2 again, get 18. Divide by 2 again, get 9. Divide by 3 this time, and get a 3. But sometimes, as we look at this, we can really write our prime factorization in exponents. So instead of going 2 times 2 times 2 times 2, we can just say 2 to the 4th power. And we're going to multiply that by, instead of 3 times 3 down here, we can just say 3 squared. So just like that, we've taken our prime factorization and written it in exponents instead of writing out every single one. But we understand the idea of how they work together. And then you can get different problems like this. 1,000 minus 10 to the 3rd. Well, what is 10 to the 3rd? 10 times 10 is 100. Times 10, that is 1,000. So in the end, our problem equals 0. Right? So big number, same size number. Exponents can seem misleading or seem like they might be bigger than they really are. The other thing that we're working with today is just reviewing the concept of writing decimals as common fractions, right? So as we read this, we would say this is 6/10. And so I say, okay, that's 6/10. But then we want to reduce, so I'm going to divide both by 2, and that's going to give me 3/5. Here, I look at this one, right? 45 hundredths. And then I'm going to think, can I reduce this? Of course I can reduce this. I'm going to divide both by 5, and that's going to give me 9/20. So that's just a review concept added into this lesson looking at exponents. So we can think about those different ideas. All right, here are some sample problems as you work with exponents and that review of common fractions. That's lesson 73.